So welcome to the last video, my last little vignette on Chapter 3, Stoichiometry. And we're going to do a practice problem involving percent yield. To determine the percent yield, or how much product is produced in a reaction compared to what is predicted, that is essentially what percent yield uses to calculate. The percent yield of a reaction is equal to the experimental yield, or what you actually get when doing the experiment in the lab, divided by the theoretical yield. The theoretical yield, another way to say theoretical yield, is the calculated yield. That is the maximum amount of product that you would produce in a reaction if everything went correctly in the lab. All the reagents worked the way we're supposed to, temperature and humidity, we were fine, everything worked perfectly in the lab. That's the maximum amount of product that you could produce. That is the theoretical or calculated yield. The ratio of the experimental and theoretical yield multiplied by 100 gives you the percent yield. Now, in chemistry lab, you're going to be doing several chemical reactions, and the amount of product that you generate, the experimental yield, will be often different, less than the predicted or calculated theoretical yield. You'll encounter that starting with the second lab on empirical formulas. When doing percent yield problems in lecture, obviously you're not going to be doing an experiment when doing these problems during the exam. In these problems that involve percent yield, I will give you the experimental yield. The theoretical or yield, which is also the calculated yield, that is what you will have to calculate and go on to use with the given experimental yield to find percent yield. So let's do a practice problem. It's worded here, and then we'll go to the next slide to work it. And I like this problem because I think it does a good job of summarizing a lot of concepts, not just from chapter 3, but chapter 2 as well, because you need to know how to write balanced chemical equations. And so in this statement, I say I have 5 grams of pentane, and I don't expect you to know the formula for pentane, but C5H12. That reaction with 5 grams of oxygen gas produces CO2 and water. 2.40 grams is produced of CO2. What is the percent yield of carbon dioxide in this reaction? So there's a lot of information there, so let's go to the next slide. So I give you a chemical equation in words. I say that pentane reacts with oxygen to give you carbon dioxide and water. I also tell you, my little pen here, I also tell you how much carbon dioxide is produced, 2.04 grams. So that is how much is produced when doing the experiment in the lab. So this is the experimental yield. I want to know what the percent yield of carbon dioxide is in this reaction. And as we just said, percent yield is experimental divided by theoretical or calculated multiplied by 100. So we need to calculate the theoretical yield for this reaction. Before I do anything, what do I need to do? Yes, I need to balance this chemical equation, because there's a lot of things that aren't balanced. I see, and I recommend if you want to do the chart method for balancing it, you can. I'm just going to talk through it. I see that I've got 5 carbons on the left side, so I'm going to need 5 carbons on the right. I have 12 hydrogens here. The only way to get 12 hydrogens on the right is to put a 6 there. Now it's time to balance the oxygens. So let's see how many oxygens. So I've got 2 on the left side. On the product side, I have, how many do I have? I have 5 times 2, or I've got 10 oxygens from the carbon dioxide, I also have 6 times 1, or 6 oxygens from the water. Adding those together gives me 16 oxygens. So to get 16 oxygens on my reactant side, I add an 8. So I now have a balanced chemical equation that I can use to do stoichiometry to determine how much product, specifically CO2, should theoretically be produced in this reaction. So before I start my stoichiometry, I look at the information I was given with regards to the reactants. I was given amounts of both reactants. I was given both 5 grams of pentane and 5 grams of oxygen gas. Which one do I use? If given reactant amounts and asked to find product, and I don't tell you which one is limiting, you got to do a limiting reactant problem, which means you need to calculate how much product, in this case carbon dioxide, comes from 5 grams of pentane in one calculation, and do a similar calculation with the 5 grams of oxygen gas. So we're going to do two separate stoichiometry calculations using that 3-step dance, going from grams to moles, moles of species to moles, in this case of carbon dioxide, and then moles of carbon dioxide to grams of carbon dioxide. So for the pentane, I change my grams of pentane into moles of pentane using its molar mass. Then use the coefficients of the balanced chemical equation. For every 1 mole of pentane, I have 5 moles of CO2. And then last but not least, go from moles of carbon dioxide to grams of carbon dioxide using the molar mass. I do a similar dance with the oxygen, making sure I use the molar mass for oxygen and the coefficients of the balanced chemical equation that involve carbon dioxide and oxygen. And then finally, molar mass of carbon dioxide. And so putting those 2 separate calculations in your calculator, you should, for the pentane, get 15 grams. And for the oxygen, you should get 4.3 grams. So from that information, you can determine what your theoretical yield is, and also your limiting reactant. Your theoretical yield is always from your limiting reactant. Your limiting reactant always produces the smallest amount of product. So that means that oxygen is my limiting reactant, and my theoretical yield, the maximum amount of product I can make, is 4.3 grams. We're almost there. I can use my theoretical or calculated yield, let's call it TH. I can use my theoretical yield along with my experimental yield to find a percent yield, which is the experimental divided by the theoretical multiplied by 100 to give you 47%. So you were able, in this reaction, according to the data that was given, this person was able to have a percent yield of carbon dioxide of 47%. Not too bad. Many times in chemistry, you will produce a percent yield that is less than 100%. So that is the end of this chapter. And like I said, I really like this problem because it summarizes a lot of key concepts, not only from this chapter, but also, writing balanced chemical equations, taking information in words and writing them as formulas and chemical equations. Congratulations for making it this far, and this is the end of chapter 3, and this is the end of the information in my online lectures for the first unit exam.